In this video, I'm going to be taking a look at the behavior that simple covalent compounds tend to exhibit. And right here, what I have is a couple of, well, more than a couple. I have quite a few molecules which are simple covalent molecules. And these kind of molecules make up simple covalent compounds. So as you can see, we've got nitrogen gas here, and we've got chlorine in a diatomic molecule form, and here we have hydrogen chloride and methane, hydrogen, we've got H2O here, water, and oxygen gas, boron trifluoride, and all of these other molecules. Now, these molecules have some characteristic behaviors which they tend to exhibit, and in terms of properties, the ones I'll start with, the one I'll start with is melting and boiling points. Now, simple covalent compounds tend to have quite low boiling points because, as you can see, although they have quite strong bonds between the atoms that make up the molecules, in between these actual molecules, they don't have very strong forces. And so because of this, they can boil quite easily. The intermolecular forces are weak, despite the fact that the forces between the bonds between the atoms, or the intramolecular forces, are quite strong. So they have quite low boiling and melting points. And now if we take a look at another property, so electrical conductivity, which is like the ability of it to actually allow a current to flow. These are very poor conductors of electricity. I know you might be thinking, oh wait, no, we have water here, very good conductor. That's not the case. Water only really conducts electricity when there's ions present in the solution. Otherwise, it doesn't conduct electricity. And for these other ones, they don't conduct electricity either, because they don't actually have any ions, free ions or free electrons which can allow current to flow, because current usually flows through the movement of ions and electrons, and they don't have any of these. So they don't, well, they have electrons, but they're not free, so these don't conduct electricity. Now, if we look at the subject of solubility, right, simple covalent molecules, simple covalent compounds are usually quite soluble, but what it depends on is whether or not the molecules are polar. And if they're really polar molecules, then they will have more of a tendency to dissolve, especially in water. In water, if the molecule is quite polar, then it probably will dissolve. If it's not polar, then it probably won't dissolve. Like here we've got methane, right? And methane is a molecule which is not very polar. The bonds are more or less, they may be dipoles in the bonds, but what happens is they cancel each other out. So overall, this molecule doesn't have, it's not really it's not polar. So this would not dissolve in water. It's not very soluble. But on the other hand, if we look at a molecule like HCl, right, and going up to the periodic table, which I have here, a hydrogen is here, and if it was in this periodic table, it would be like here, and chlorine is over here. So there's a huge difference in electronegativity. Chlorine is going to be much more greedy with the electrons, and therefore this is going to be a polar molecule. And the way we represent what dipoles, slight positive or negative charges, the way we represent this is with a little d, and for the chlorine would be slightly negative, and hydrogen, since it's sort of being more generous with the electrons, it's not being really greedy like chlorine is, it's going to be slightly positive. And so when this is like a permanent dipole, this is what we call a permanent dipole, because it literally stays like this. This is going to be slightly negative all the time. and this is going to be slightly net positive all the time. And when this dissolves in water, and this is a water molecule I have here, this is going to be, the oxygen is going to be slightly negative, and two hydrogen molecules are going to be both slightly positive, so slightly positive and slightly positive. And so when you put this in water, what happens is usually for this particular, this is hydrogen chloride, hydrogen. What would usually happen for this particular molecule is it would be really soluble, and when it's dissolved in water, these water molecules can actually pull this bond apart, since there's such a great difference in electronegativity, and it can form HCl, so aqueous hydrochloric acid. And so yeah, since this molecule is really polar, it would dissolve in water, whereas the molecules a lot of these other molecules aren't really that polar, so they're not gonna dissolve in water. Oxygen, I mean, not oxygen. Yeah, oxygen. Oxygen would more or less dissolve in water. And yeah, pretty much, yeah. So those are the 3 different properties which these molecules exhibit. And yeah, so I hope you guys I hope you find this video helpful, and I'll see you in the next video.